Hello, everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is Part 5, Performance Testing, Setting up Dynamics 365 Commerce, Performance Test, POS Ecommerce. My name is AJ, and I will be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on TechTalk's Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Chris Bittner and Rob Bertram will be responding to your questions in the chat during the presentation. Thank you for your patience during these announcements. I'd like to start by letting you know who's presenting for us today from Microsoft. We have Srinath Sundaresan, who's a Fast Track Solution Architect, and Fabian Chiramel, who's also a Senior Fast Track Solution Architect. And without further ado, Srinath, the floor is yours.
Thanks, AJ, for the introduction. Before starting the Tech Talk, here is a slide on the implementation guide for Dynamics 365. If you have not already seen this, we recommend you to go through the implementation guide. This is a must read for any Dynamics 365 implementation. Please refer to the performance section in Chapter 17 of the guide, which provides insights into building a performing solution. The objective of this Tech Talk is to provide guidance to implementation partners and customers to do performance testing for the Dynamics 365 Commerce solution. Our focus during the Tech Talk is to reduce complexity and generate awareness of planning and execution of performance testing in commerce scenarios or environments. We will also look at some sample scenarios and tools you can leverage to perform the testing. We will demonstrate load testing on commerce scale unit with tooling, and it will generate performance reports. We will also look into automation of load tests and ability to run these tests in a repeatable manner with very less user intervention. Later, we will provide insights on how to analyze and optimize performance issues. We don't cover back office performance testing in this Tech Talk, as this has been extensively covered in previous Tech Talks of the performance testing series. Please use the Q&A panel if you have any questions. Here is the agenda for today. First, we will provide an overview of commerce performance testing. We will start with real-life customer scenarios and talk about commerce architecture and discuss the factors that affect channel performance. We will discuss the high-level approach that we should use for Dynamics 365 commerce performance testing. Then we move on to how to plan, prepare, and execute commerce performance testing. We have planned 4 demos for today, where we will showcase load testing against commerce scale unit for POS and e-commerce scenarios, and we will cover the automation of test cases. We will also cover some tools which can be used to simulate the load for the performance testing. Finally, we will analyze the performance results and provide some tips on how to analyze and optimize the performance issues in the solution. As you might know, this is one session of a series of Tech Talks dedicated to performance testing. There are previous Tech Talks in the series which have been recorded and made available for your reference, and other Tech Talks on additional topics will be added to the series in the future. Let's begin with the overview and real-life customer scenarios. Here are some of the customer scenarios. Customer is planning multi-country store deployments and want to ensure the store performance. Second one is customer is rolling out e-commerce website for worldwide customers and wants to ensure the site availability and performance with peak number of visitors. Another scenario is customer wants to prepare for flash sales for promotion events and festive sales. Last one is customer wants to know the number of commerce scale units required to operate 2000 to 3000 devices. In all these cases, the implementation team wants to ensure the performance, scalability, and build a solution which enables the customer and the business to achieve its goals. Here is a quick refresher on the commerce architecture. At the heart, we have the commerce scale unit, which hosts the headless commerce engine. It serves as the central integration point for all commerce business logic and powers a complete omni-channel solution across physical and digital stores. The headless commerce engine powers all native Dynamics 365 commerce channels, including in-store and e-commerce channels. Then we have the POS client, EPOS or CEPOS, and now the new store commerce app, which the customers can update. Let's discuss some of the tooling. Here is a summary of the tools we will use during the demos. We have used Apache JMeter as the test authoring and report generation tool. We have used the preview Azure load testing service for high scale load and monitoring. We have also used Azure DevOps for building the DevOps pipeline and integrating the performance testing as part of the CI/CD. In some cases, channel performance might not be good as you expected. Typically, when you test the performance of a system, you should focus on components where there is competition for many shared resources. These resources might differ for different projects, customers, or requirements. For example, if there is a system with very high number of real-time service calls, then there is resource contention for real-time service. And the bottleneck or competition is for RTS resources. Poor performance is often caused by multiple factors, typically in a commerce implementation. High number of real-time service call is known to create performance issues as the calls go to headquarters to directly update the back office. Too many number of real-time service calls can cause performance issue in the implementation. Avoid RTS calls and try to make the operation at the channel level to improve performance. Frequent and chatty calls with the commerce scale unit with complex business logic can cause performance issues. Try to make fewer calls or reuse standard API calls when extending the solution. Caching in the CRT request handler can also be applied as appropriate. Adding complex logic in custom calls can also decrease performance. Try to use standard calls and, if possible, use existing calls to bring additional data that can improve performance. If you are writing additional channel database extensions, make sure your custom SQL is efficient and uses correct indexes. Also follow the T-SQL best practices. We have seen customers integrating the retail server with third-party system through multiple middlewares and legacy systems. It is crucial to test the dependent middleware systems also for performance and availability. This is one of the areas where I have seen the highest number of performance issues. Latency is also an important factor when connecting to the headless commerce engine. Please use tools like Azure Speed Test to measure latency to the deployed commerce scale units. Last but not the least, the data volume and configuration is a major factor influencing the performance. For example, a larger data volume can cause performance issues when retrieving and manipulating data. Incorrect configuration can cause performance issues, like, for example, convoluted pricing and discount setup can affect pricing lookup performance. In this tech talk, we will take the approach to test the performance of Dynamics 365 Commerce Scale Unit APIs. For example, If you want to test the checkout operation from 100 point of sale devices, in the test, we will run performance testing with 100 emulated devices and connect the checkout API and simulate the checkout operation. We are not using any UI, and instead we trigger the APIs to perform the operations. We are not doing UI rendering performance testing, but focusing on performance issues mostly caused by the business logic or chatty calls to the commerce scale unit. UI operations aren't considered bottlenecks because they have their own dedicated resource. We don't recommend that you use a production environment for performance testing. A good practice is to use the same configuration, development, test, and production environments. The development environment can then be used to work on and verify a fix. Because many performance critical code paths are data dependent, the same issues might not be seen for contour sample database. For e-commerce, the test profiling of UI components is still relevant. You can use tools like web page test and Lighthouse for generating performance reports and profile the React components rendering. Let's now go into the planning phase. Before starting performance testing, the team should go through the planning phase and generate a detailed performance test plan. The test plan should contain details of commerce performance testing, like the list of critical business processes, for example, checkout process, price lookup, customer creation, etc. Now identify the expected concurrent devices or users who will perform the operation. This will later translate to number of virtual users simulated during the performance test. For example, 100 devices will run checkout operations concurrently. Next step is to identify the peak sale transactions. The number is also required to be filled in the usage profile of the subscription estimator. For example, there will be 40 checkouts per register in the peak hour. Identify where will the registers be physically located, which commerce unit they will be connected to. Now identify the duration and the load test pattern. For example, checkout operations will be performed for a duration of 1 hour with 100 devices. For e-commerce, we also need to determine the number of visitors per hour to calculate the volume of operations. For example, there will be 500 e-commerce API requests in 1 hour. Planning and executing commerce performance tests requires an understanding of the commerce API exposed by the commerce scale unit. There is documentation available in the doc site for the CSU API. Then we will need to decide on what are the different functional scenarios or APIs that should be called. What will be the load generated for each API? How can we set up concurrent session or parallel sessions to do the load test? There will also be need to have resources available with that technical or functional experience for the activity. Last, determine all the prerequisite data like configuration, data, and master data like customer, worker, etc. required to complete the test. Now I will hand over to Febin to cover the preparation activities.
Thanks, Srinath. Let us now move to the preparation phase. The first step is to prepare the performance test environment. Make sure a tier 2 or above environment is deployed. Please go through the previous tech talks on environment strategy to learn more. Once environment is ready with data and configuration required for the performance test, make sure the required number of devices and registers are created in back office to simulate the load. Now start preparing the test cases and test scripts. This will cover number of users, devices, and the duration of the test runs with ramp-up time, etc. Prepare for coverage of functional scenarios like whether it is card payment, guest checkout, ship or pick deliveries, and how many products added in cart, etc. Also make sure there is an ability to extend the existing test cases. For example, if there is a new custom API, can this new API be added at later stage to the test? The next step is to identify the commerce APIs required for commerce performance testing. Based on the test cases, these APIs need to be identified. For example, there is an API named add cart line, which is called when user adds a product to the cart. Similarly, there is an API for checkout operation. This is called when customer complete the transaction from the POS or e-commerce by making the payment. The commerce APIs are building blocks of the test script, and each test script will contain a collection of APIs, which are tested for verifying the performance. You can use browser developer tools or Fiddler to easily identify the APIs for POS and e-commerce operations. The implementation team can then author the test script for performing performance testing. We will show you how you can use JMeter tool to prepare the test scripts. JMeter is an open source load testing tool to script performance test cases and simulate the requests. The script will trigger commerce APIs with pre-configured data and get executed to produce test reports and results with response times. The test results generated during each iteration is tracked for issues which need to be analyzed and mitigated. Once the script execution is successful, then we should prepare for generating high-scale load on the APIs being tested. We have seen customers use Azure infrastructure to generate high-scale load. Finally, you can plan the automation of the load test. This includes the ability to provision and destroy infrastructure for load test automatically based on the configuration. In an implementation, the project team wants to author and create performance test cases and scripts that can later be executed iteratively over multiple iterations. In the coming demo, we will showcase how to identify the APIs and author the performance test scripts using Apache JMeter. The expected outcome is a collection of test case scripts with detailed steps and associated test artifacts for both POS and e-commerce. We will start the demo now.
In this demo, I will show you how to identify the APIs which are called from a POS application and how to prepare the test script for automation. I will open CEPOS application now. And I will open the developer tool options by pressing F12. Okay. So you want to complete a checkout operation. So go to categories and find a product. Add this product into cart. So as you can see in the right side, the cart operation is called, then add cart line is called. So cart is created, add cart line called to create the cart lines with the product we selected. Now we do the cash payment and complete the checkout. So you can see the tender line is created for payment. Then checkout API is called to complete the checkout operation. So these are the major APIs which we would like to identify. And there are other APIs which you can use if you want to modify the script. So this is one way to identify the APIs. There are other tools, for example, Fiddler to capture the network calls and the APIs, and also other third-party tools. Now we are clear with APIs, which we need. Now we can move to the test script preparation part. So for that, we are going to use Apache JMeter to prepare the script. JMeter is an open source testing software. It is designed to cover various tests such as load testing, functional testing, regression testing, etc. So I have downloaded Apache JMeter files. Now I will open up the JMeter tool, go to the bin folder and click on jmeter.batch file. So Apache JMeter tool is opened. Now the plan is to prepare a script that will do the checkout with 2 products in a cart. And also we want to simulate this checkout operation with a set of devices. So we prepared a list of devices and we prepared a list of products. I will show you the CSV files which we prepared before we jump into the script. So go to the test folder. So here is the product list which we prepared. So we have added 2 lines with 2 products. That means a cart is created with 2 products and 2 lines basically. The other CSV file is for devices. So we have uploaded the username, password to log in into a device and a device token to authenticate the device and the device ID, terminal IDs and other device properties. So we have identified 13 devices and collected the information and prepared the device CSV list. So if you are struggling to identify the device token, you can go to the Retail SDK and you can use the sample files which we shipped, and there is a test client. You can use this test client to identify the device tokens. Now we have prepared a sample test script. I will open the sample test script and I will walk you through the sample test script. So this is the script we prepared for a checkout operation. We have configured some of the variables which we need to use in every operation. So one is retail server URL, the other is device type, cache drawer type, etc. Then we have uploaded the device list so that system can choose any device to log in and complete the checkout operation. As you can see, these are the steps in this script. So one is to do the health check, then set the transaction ID, then device logging into the device login operation. Then we check the shifts. If the shifts are not open, we will open a new shift. Then we have added some custom APIs. Then we are creating a transaction. For that, we create a cart. Then we again go back and select that product list file so that we can loop through that records. So in our case, there are 2 records. So this add cart line is called 2 times. Once the cart line operations are done, we call the tender line, we call the checkout, then end the session. So this is the basic structure we prepared. Now, there is another important factor in this script, that is thread properties, where you can define the number of users or number of devices which need to be used and in what time period. So for example, if you set 8, that means 8 devices will log in 60-second time and try to complete the operation. So before we jump into multi-threading testing, we will test this script with one user and verify if the script is working fine or not. So I set up user threads as 1 and ramp-up period as 1, and I start this operation. Once you start, you can go to the result tree and see the calls happening. So all the calls are successful. It just completed. Now you can go to the summary report and see the average latency for each API calls. So as you can see, there are some API calls taking time. So we need to investigate each API calls and understand where the time is taken. So we have a demo in the coming session. We will explain you how to analyze each API calls and how to fix the issues. Now we will go to thread properties again. Here now we want to change this into multi-thread options. That means we want to simulate this login with different devices and for a period of time. So here we have a list of 13 devices. I set these threads as 15 for now. And we keep the ramp-up period as 20 seconds. I clear the log. I'll start the operation. You can go to the view result tree. You can see the device authentication. So here you can see this is Houston 5. This is Houston 3 device. This is Houston 2. This is Houston 6. So basically we are simulating different devices and completing the checkout operation. So this is still going on and it just completed. Now if you can go to the summary report, you can see that, okay, it got executed, checkout got executed 15 times. And you can see the average latency. So there is one API which is standing out and all other APIs completed with an average 500 millisecond time frame. Now we need to identify what is wrong with this API. We will do an analysis on that. Otherwise, this script is working well and our goal is reached.
Now let's take a look at the activities in execute phase. Here we are going to see simulation of high load. In every perf test implementation, you should plan for multiple iterations of performance testing. The first iteration can be on a lower volume to understand the bottlenecks in regular operation. After the first iteration, implement the optimization required for the improvements. Once first iteration is cleared, plan for high load simulation and ramp up to the expected volume over subsequent iterations. This may contain further optimizations to solve the performance issues. The load test should be able to scale with the required number of users or devices and run these tests on schedule. We will do a demo where we will be generating high scale load using Azure Load Testing Service. Azure Load Testing Service is a new preview feature available from Azure Stack, which can be used to increase the load seamlessly with configurations. You can use LCS monitoring logs and operational insights to identify the bottlenecks and error messages. The results should be recorded for all iterations and compared so you can assess the progress in each iteration. Once the test runs are completed, evaluate if the load test criteria is met. In this scenario, the customer is planning to roll out high number of POS devices and wants to ensure the store performance under peak load. The implementation team should be able to perform the performance testing to meet the peak load expectation of customer. Here we are going to simulate the load test for high number of devices with Azure Load Testing Service. This is a brief introduction about the architecture before we jump into the demo. Azure Load Testing Service is a preview feature available today, which can fully manage load testing that can be used to create high-scale load. Azure Load Testing engines abstract the required infrastructure for running high-scale load test. The test engines run Apache JMeter script to simulate large number of virtual users, simultaneously accessing your application endpoints. To scale out the load test, you can configure the number of test engines. The load testing service will be pointed to the retail server URL for load testing. We will supply load test artifacts like JMX script, configuration files based on the test scripts we prepared. Azure Load Testing Service supports up to 45 engine instances for the test runs. In the previous demo, we prepared the test script. Now we will move to the next demo where we can showcase the Azure Load Testing capabilities to scale up the volume.
In this demo, I will show you how to utilize Azure Load Testing Service for simulating high load. Before we start with Azure Load Testing Service, we need to modify the JMeter script to match with Azure Load Testing Service. So I will open JMeter tool now. I will open the sample script we created. The first thing we need to remove the folder dependencies from this configuration. So I just remove the folder path and I just keep the file path. I mean file name. I do the same for product list. I remove the folder path and I just keep the file name. Now we need to adjust our number of threads, the thread properties. Since we have only 13 devices captured, I will keep the number of threads less. And I will try to run this more number of times. I'll keep the ramp up period less. So this is what I'm planning. In your case, if you want to run 100 devices, make sure you capture the device details with device token for 100 devices and run the test with 100 devices. I'll save this file. Close the JMeter tool now. The next step is to create Azure load test service. For that, go to the Azure portal, search for Azure load test service. Create a new testing service. I created a new resource group. And I just created the load testing service. Deployment is completed. The new service is created. Let's go to the resource. As you can see, there's error message here. So you need to make sure that the user you are going to use for testing service is added with right roles. So go to access control, click on add role assignment, select load test owner, and also select load test contributor. In this case, I select load test owner. Go to the members, select the member. So I select my user ID. And I create the role assignment. Just refresh your screen. Now you can see the create a test button is enabled. Let's create a test. Okay. Now unselect run test after creation option. We will run this test manually. Go to the test plan tab. Here you need to select the JMX file and other files. So here we have device CSV file and the product list details. Go to the load. Here you can configure the engine instances. In our case, we will set up 2 engine instances so it can run parallel. Now we configured the test. We can review and create. So you can see the test is created. Click on the test. Here you can start the test by clicking the run button. I click run. So you can see a test run is created here. And you can see the status. So now the status changed to provisioning, change to configuring. It will move to executing now. You can click on the test run. It will open up the details screen. As you can see, there are 2 engine instances running and the status is executing. We can see a dashboard appearing here. So test is executing. You can see that there are 8 threads running parallel. You can see the response time in the right side in the dashboard. So there are API calls happening with 500, 300 millisecond response time. It's still executing. Okay, the test execution is completed. It took around 1 minute 9 seconds. So here you can see the dashboard. If you want to analyze this in detail, you can download the results into a CSV file. I'll just open up the CSV file. You can see all the URL calls and the latency. So you can use this CSV for the detailed analysis.
Now I will hand over to Srinath to walk us through the next demo.
Thank you, Fabin. In the third scenario, customer is rolling out Dynamics 365 Commerce Storefront and wants to ensure site performance when there are maximum number of visitors in the site. They plan to run multiple iterations of performance testing and want to automate the load testing. For performance testing e-commerce API, we have returned the sample JMeter test file. We have passed some configuration values into the test script, like which commerce scale unit to use, which B2C tenant to use, etc. We are first making a request to the B2C tenant to obtain the ID token. We will be simulating a signed-in customer in the storefront. The ID token for the successful sign-in is issued by the B2C tenant. We have to send the ID token in the HTTP header for all the subsequent calls to the commerce scale unit. We will be testing scenario of adding an item in the e-commerce cart and placing the order. Through this scenario, we will be making multiple API calls like add cart lines, checkout, etc. We start by making a cart request, create the cart. Then we trigger other API for product discovery and pricing. And finally, add an item to the e-commerce cart by making the add cart lines request. Then we proceed to updating the shipping address and delivery options. Finally, we make a call to the checkout request to place the order. I will now add a new request here to the custom API, a new HTTP request, and name it get all example entities. Now, we will add more details to the request like CSU URL and API path. So we are going to paste in the parameter for the CSU URL. I am going to put the protocol as HTTPS, and I will also add the full CSU URL path. Now, there are a few more additional details that we need to fill. I'm going to pass the body data that, and also I am going to pass the header information. I'm going to copy paste the header information from another request. So in the header, we are going to pass the authorization token as well as the operating unit number. Now, I will move this request to the top of the stack. Now we are ready with the script and I am going to execute. If you notice, the first few API calls are going to be to fetch the ID token. And after we fetch the ID token is also passed in the request header for every subsequent call. Now, if you see this stack of API calls, you will notice that we are making some calls for active prices, so, getting variant by dimension values, and we are placing the item in the cart, and also we are making a checkout request. And we have noticed that the first execution of the script has passed successfully. Now let us check if the transaction has been created in the commerce headquarters. I will copy the transaction number from the checkout request response. Now let's go to online store transactions. Let's add the column for transaction number. Now I'll filter the transaction number column for our transaction. Here we can see the transaction has been created successfully in the Commerce HQ. To simulate a higher number of users, I am going to change the number of threads to 10. And I am also going to change the loop count to 10. Now we have the test script ready. Now we are going to use this test script to load test the e-commerce APIs. For that, we are going to use this test script in the Azure load testing service. Let us go to the Azure load testing service. We will create a new test in the Azure load testing service. I am going to name this test ecom perf test. I do not want to run the test immediately after creation, so I am going to uncheck this box. Let's go to the next. Here, the test expects a JMX file. So I am going to upload the test script or the JMX file I created for the e-commerce API test. We'll upload this file. Then I am keeping all the other parameters as standard, and I'm just going to change the engine instances to 2 so that we can emulate 20 users testing the e-commerce API. Then I'm going to click on create. The ecom perf test has been created. I am going to run this test by clicking on the run button. The load testing service shows the running status and the number of engine instances that we are using to run the performance test. We can refresh and see whether the test run is getting executed or not. Yeah, so it has started the execution. Now I am going to wait till the execution has finished. The execution is complete now. We can see the results in the dashboard. So from this dashboard, we can see there were 20 virtual users that were running the scenarios, and we can also see the response times. We also notice there has been no errors during the execution of this script. We can download detailed files and logs from the download tab of the Azure load testing service. Next, we will see how we can automate load testing using the Azure DevOps pipeline. For using the pipeline, I have created a repository with all my required test artifacts. I have placed the API test e-commerce signed in.jmx file in the repository. I have got two other files. These are the pipeline definition and the load test configuration file. First, we will go to the load test configuration file. The load test configuration file, I am giving some information to the pipeline. Like I am going to use the test name e-commerce perf ecom perf test. I'm going to use the test plan, which is the name of the script I am going to execute, as well as how many instances I want to use to execute the script. Now I have also created a pipeline definition file, which has information about which subscription, which service connection I'm going to use. Also, where are my Azure resources placed for testing? Like for example, my Dynamics 365 load testing resource is in the D365 for FO ALM automation resource group. And also I give some metadata information like which location are the resources. Now, when you go into the stages, it contains all the tasks that needs to be executed by the pipeline. So the only task that we are going to execute is to trigger the load test. That is a summary of the files and the contents of the repository. Now, what I'm going to do is I am going to create a new pipeline. I am going to give the source as Azure repos git. I'm going to select the repo, and I'm also going to select the existing Azure pipelines YAML file option. Here, I'll select the path of the YAML file. Now, the pipeline is ready. Now I am going to run the pipeline. So the job has now finished. We can see detailed information in the information logs. The information log contains a link back to the Azure Load Testing Service dashboard. It also has information about the client-side metrics, the response times, the total requests, and other information related to the performance test. So we have seen how to set up performance testing of e-commerce APIs using JMeter as a load testing tool, as well as Azure DevOps pipelines. We have seen how to plan and execute performance testing for Dynamics 365 Commerce. Now let's take a look at how we can analyze the performance test results and mitigate issues. In this scenario, the customer has reported an issue during performance testing where updating the store hours for a channel is taking a lot of time. The implementation team should analyze the reported issue and provide a mitigation. We will analyze and mitigate an issue raised by the customer during performance testing. To analyze this performance issue, we need to look at the low-level telemetry data. Telemetry data can be accessed by authorized users via the environment monitoring features of lifecycle services and can be filtered in a few different ways. First, we'll go to the environment in LCS and select environment monitoring. Now, we'll go to the activity tab and select channel events. Let us put in the time duration in which the performance scripts were run. Now let's select the log source as the retail cloud scale unit. You can also filter additional details if you have, for example, the activity ID or the app ID. We will also change the records to output to 5000. The results can be exported to
an Excel file. So Excel is not an optimal tool for advanced querying of this data. A tool that is better designed for this purpose is the Azure Data Explorer. It provides innovative query language Custo that is optimized for high performance data analytics, answering questions like how often a certain process has occurred, how long has it taken in 90% of the occurrences, how often per hour has a certain action taken place over the course of a day, becomes a lot easier, and it can be backed with powerful graphics as well. So first, let's export this data out and let's ingest this data into Azure Data Explorer. We will use a Azure Data Explorer cluster and ingest the data as a table into the database cluster. We will go to the cluster and ingest the data from the file. So I will give the name of the table as traces. Now I will upload the file that I downloaded earlier from LCS. So this is the file I downloaded earlier from LCS. Now I am able to see here or preview the data, and you can verify if the data looks correct and the columns correctly appear here so that you can proceed. Complete this data ingestion. Now the process is complete. Now after ingesting the data into the cluster, we can gain insights into telemetry and write queries to analyze the data. So let me close this. Okay, the first query I'm going to use to analyze the data is to see the SQL statements that have been executed during the time window and to check if there are any slow queries. We are going to sort the records in descending order for execution time. We see that the highest query is only a few milliseconds. The remaining queries are also below and looking fine. Now we move on to analyze the API request made during the time interval. I have written a Custo query which summarizes the execution time for each API in a column chart. We are summarizing here the average duration it took to complete the commerce scale unit API request. I will run this query and check the results. In the result, we see a huge tower for an API update store day. We can also see the data in the table format and gain more insights on how the API has been performing over time. Now we will deep dive into the update store day by store request and see what logic in the API is causing the issue. To narrow down to specific requests, we need the activity ID of the request. We can get the activity ID by running this query. After we have the activity ID, we can filter the telemetry data for specific instance of the API call and see the logs for that activity ID. This can help us narrow down the issue. So here is the results after running this Custo query. So we see here there was a real-time call made to the back office, which is taking the most of the time. So there is a real-time call happening in the request. So after executing the query, we see that the larger portion of the execution time is being used for this real-time service call. We will see the code and analyze the real-time call. We will look at the request handler for the API request and check if there is a real-time call happening. This is the real-time call we are interested in. The method name we are looking for is Contest retail hours, update store hours. Now we will look up this method in the Commerce HQ. We will go to the retail transaction service extension class. As you see here, this is the method that is being called by the real-time service. If you look at this method, we are updating this table store hours with information that is coming from the POS. So what we can really do here is we can completely skip this real-time call. We can make this call even the channel side. As you noted during the demo, a large part of the request processing time was devoted to making a real-time call to the back office. Here in this case, the real-time logic to update a record in the store hours master table can be moved to the channel side. By moving the logic to the channel side, we are not making a service call back to the commerce headquarters. The commerce data exchange jobs can be set up to sync the store hours data back with back office instead. After we make these changes in the channel side, to remove the real-time service and move that to the channel side, we can deploy a new package and see how this has mitigated the issue. We have made the changes for moving the logic in update state day hours to the channel side and deployed a new package in the commerce scale unit. We have run another iteration of the performance test. We will go to the environment monitoring and how the changes have affected the performance in the update store day hours API. I will ingest the new file that we downloaded from LCS. I will give it the same table name. Just verify the data looks fine in the preview tab, then we are going to proceed to complete the ingestion. Ingestion is complete. Now let's go and rerun the previous query to see how the APIs are after we made the changes and how the performance testing is in the second iteration. So we see the update store day hours, the time taking is has reduced. You can also see that in the table. So the changes we made for moving the real-time call and moving that changes to the channel side has improved the performance of the update store day hours API.
Now it's time for the Q&A. Are there any questions which are not answered through the chat?
No, there is no open questions.
This concludes today's session on Dynamics 365 Commerce Performance Testing. I want to invite you all to the next Tech Talks, which will cover more details regarding performance testing in Dynamics 365. Thanks everyone for joining this Tech Talk.
Thank you for presenting it for us. As a reminder, I've posted a short link to a survey in the Q&A panel. We'd love to hear your feedback on today's session and what you'd like to see in future events. Any participation is appreciated. As a reminder, the recording of today's session will be available on TechTalk's Community Dynamics page within 5 business days. And once again, I'd like to extend a thank you to our presenters and those helping in the chat. And this concludes today's event.